Hello friends and welcome to another lecture on chemical engineering thermodynamics, and today we will be seeing a problem which has come in Mumbai University Chemical Engineering Thermodynamics 2 paper May 18, problem number 5A, and the problem is on your screen. Now this problem was for 10 marks. Now remember one thing, this problem can be solved if you know how to solve it, otherwise it's going to be very tricky. So a gas mixture containing 25% of carbon monoxide, 55% of hydrogen and 20% of inert gas is to be used for methanol synthesis. The gas leaves the catalyst chamber at equilibrium. So a few corrections, I normally tend to take the questions as it is, and there's a full stop here. Okay. The reaction is carbon monoxide plus 2 hydrogen gives you methanol. Okay. Find the composition of gas leaving the reactor. Assume that the gas mixture is ideal and K phi is 0.35 and Kf is 4.9 into 10 raised to minus 5. Now, the fundamentals are very important here. If you remember this equation, you have almost solved the problem. It says that the equilibrium constant is given by minus delta G 0 RT is equal to ln K. Now, what is delta G 0? Delta G 0 is the Gibbs free energy of change of the reaction. Okay, at the temperature of the reaction. This 0 does not mean 298. Many of these students make a mistake by assuming that this 0 is 298. No, it is not. This delta G0 is the Gibbs free energy change of the reaction at the temperature T of the reaction, but the 0 here indicates that the reaction is being performed at P is equal to 1 bar. That's the very clear understanding about this. Many people assume that this 0 means 298 Kelvin. Wrong. Sorry, you're absolutely wrong. This 0 indicates that the reaction is occurring at 1 bar, but the temperature T, whatever the temperature might be for the reaction. Okay. Now, we can write K is equal to product of along I components, product of I components Fi cap, where Fi is the partial fugacity raised to nu I, where nu I is nothing but the stoichiometric coefficient of the reactant or the product. Now the stoichiometric coefficient nu I is positive for product and negative for reactant. So always remember one thing, for stoichiometric coefficient PP, positive product. Okay. Therefore we can write it phi I, Fi can be replaced as phi I cap into Yi into P, because the definition of phi I cap is nothing but Fi cap by Yi into P. So by this we get this, and therefore we can write K as this equation by replacing Fi cap, and we can write it as K phi into Yi into P, where you remove product of all the phi i's raised to nu I, you take it as one factor K phi, and the K is nothing but Kf, because K here is a function of the fugacities, the partial fugacities. So K is now here Kf. Now we take the basis as 100 mole of feed. So what is entering the reactor? 25 moles of carbon monoxide, 55 moles of hydrogen and 20 moles of inert. The methanol is not entering in, and the moles after reaction, that is the product leaves at equilibrium. So after reaction means it's fairly simple here, at equilibrium. Okay, at equilibrium. Now at equilibrium, this is going to be 25 minus the stoichiometric coefficient into epsilon, the extent of reaction, 55 minus 2 into epsilon, that is the extent of reaction. Now the idea of extent of reaction is fairly simple here, that change in number of moles of any component I during a reaction divided by its nu I, that is plus minus. Plus is for product, negative is for reactants, and nu I is nothing but the stoichiometric coefficient, is equivalent to d epsilon. Okay, where epsilon is nothing but the extent of reaction. Okay, now using that we get these two equations. Why? Because -1 and -2, because carbon monoxide and hydrogen are nothing but they are the reactants, and the product is methanol, and the methanol has a stoichiometric coefficient of 1, so we have epsilon here. So the mole fraction, so when we add them up, okay, so this will be at the exit of the reaction. So when they add up, this would be the moles leaving. Okay, so the mole of individual component leaving divided by the total number of moles leaving is nothing but the mole fraction after the reaction. Okay, that is, this is the mole fraction of carbon monoxide, this is that of hydrogen, this is that of methanol, and inerts, of course, we are not noting it down. Now, what do we have? Okay, now we know that K is going to be equal to Y methanol, okay, into P the whole raised to 1 by Y carbon monoxide into P Y, okay, and then afterwards this is Y hydrogen into P the whole raised to 2. Now why is it whole raised to 2? Because the stoichiometric coefficient for hydrogen is 2. So when we replace what we have got in this column, that is mole fraction after reaction, when we replace that in this equation, of course this equation is nothing but it is, okay, right, it's this. I've just expressed it in individual terms now, right? And then of course you have this k phi kf here, and then you have k phi here, and then this is multiplied with this. Well, it's written here, it's very clearly written here. Okay, so what do we have here is we replace yip, and this is the expression we get, right, in terms of epsilon. Now whenever you want to solve it on the calculator, simplify the expression the way I have shown it. Epsilon should be on the LHS and epsilon should be on the RHS if you want to simplify it on Casio FX991 ES. It works like a charm if you show it the way. Whenever you want to solve an expression where you want to estimate any value, you should have the value to be estimated on the LHS and the RHS both sides. Now let's solve this. Okay, so let's do it now. Alpha x is equal to, oops, no, alpha x, where is x? Yes, alpha equal to, then afterwards 315 divided by, so start and end the bracket, plus 12.6. Okay, so here we have it here now. This is going to be the square of that. Yes, and then we have a fraction here, that's going to be 100 minus alpha x, and that's going to be 55 minus alpha x, right? So just put shift, solve, and start with some value. Let's start with 20 and solve it, and we get 17.9896. So I have noted it down, 17.98. So the value of epsilon, that is the extent of reaction that we get here, is the value of extent of reaction that we get here is equal to 17.98. So we have made a note of it. This is the extent of reaction. Now the conversion obviously is going to be equal to, conversion is going to be in terms of percentage is going to be equal to 17.98. Now this is what has been reacted, the monoxide which is reacted, and of course it is in the limiting reactant. Why? Because it is 25%, right? And Fed was 25, right? So what we have now is 17.98, that is reacted, divided by Fed, that is 25. So multiplied by 100. And that is what we have now. So this is 17.92. So the conversion that we have is 17.92% on the basis of carbon monoxide. So as you saw, friends, this was a very simple problem to solve, and it is for 10 marks. If you understand the fundamentals, it's a very simple problem to solve. And such kind of problems are extremely common in GATE, extremely common in university examinations. So be sure that you thoroughly revise this problem before going to the examination. You would be benefited out of it. And yes, please subscribe my channel. That's very important to me. My current subscriber base is only 612. I need to touch 1,000 subscriber base as soon as possible. And do write comments. Do write in your comments the videos that you would like to make me to make. So that was all about this problem. Goodbye, friends. Have a great day.